Hello all. So today we will be going to solve this daily LeetCode problem, minimum obstacle removal to reach corner. So let me quickly explain you the problem first. So we are given one 2D integer array of size mn, and in this 2D array we are given two values 0 and 1. So this 0 represents an empty cell and 1 represents an obstacle. So what we need to do, we need to somehow reach from this 0, 0 coordinate to the last coordinate, this let's say m minus 1, n minus 1. So in order to reach, we can travel in all four directions. So we need to return minimum number of obstacle that needs to be removed. So if we want to move over here, we need to remove this. So this goes empty, and we need to remove this, so this goes empty. So we will get this path. So it requires, from reaching 0, 0 to m minus 1, n minus 1, it requires to remove two obstacles. So in that, if we are traveling from this path, we will need 2. If we are traveling from this path, we need to remove 1, 2 and 3. And if we decided to travel here, then go down over here and here, so over here as well we need to remove 3 obstacles. So the minimum number of obstacle need to be removed from reaching initial position to the final position. We need to return that. So over here we have returned 2. So how we can solve the problem? So we know we are having initially we are at 0, 0 coordinate, and we can travel in all the four direction. So if at any position we are having obstacle, so we know okay, if we want to reach at that position, we need to remove it. So whatever cost we require to reach this point, plus if there is an obstacle, we need to add addition of 1. So we need to add 1 over there if there is an obstacle, and if there is no obstacle, we don't need to do anything. We can directly take the number of steps, number of obstacle that need to be removed for reaching the initial position. We can directly add to the one which is having an empty cell. So what we can do, how we can solve this problem? So in order to solve this problem, we know okay, we are at 0, 0. We will try all the four direction and will populate which all position we can reach, and will calculate for reaching that position how many obstacles need to be removed. So let's say if we got x, y, z, and let's say this is v. So now we are having four positions that we can reach from our initial point, and we know how many obstacles need to be removed for this. So for whichever position we require the minimum one, we can take that one and we'll explore that direction first, because this will definitely give us the minimum for the further directions, right, for other directions. So how we can solve this problem? So we can maintain a priority queue. This priority queue will ensure we will got a minimum required obstacle removal cell, and we'll try to explore all the four direction, and we'll put all the uh, we will put the required number of minimal obstacle required to remove this from the cell, will having those, and from those we will again kind of explore the one which is having the minimum one, right? So this can be taken care by our priority queue. So we keep on doing it, and once we reach to the position, a required position, which is m-1 n-1, will return answer for it. So main question is ki how we are ensuring ki we will going to get the minimum path over here, because every time what we are doing, we are only taking out the one which requires the minimum. So further when we explore it, we will definitely got the minimum for the other one. And once we reach at any cell, any particular cell, we will not going to consider it again, because we know okay, we got the minimum obstacle removal to reach this position, we have already taken care of it, so we will not going to visit this again. So we can maintain one visited array for it, and we will keep on exploring the other which are not visited, and we keep on marking them visited, and in that way we can solve the problem. So in this problem we can use a priority queue plus BFS, breadth first search, right? Breadth first search. And at the end what we can do, we can return our answer. So let me quickly code this problem. Yeah, over here I can code. So I can take this A, and M is the number of rows, N is the number of column. Now I need to define a priority queue. So we can use the STL function of C++, and over here I need what I need for priority queue, what needs to be stored. So we all know we first need the number of obstacle that needs to be removed, and the position at which I came at. So for this minimum I reach to this position, and from this position how many position I can explore. So I can explore all the 4 directions. So I need 3 values in my priority queue. First is the minimum obstacle that need to be removed, and the position where I can reach. So let's take a pair of integer, and again pair of the coordinates. Let's give us the queue, and we initially at coordinate 0 comma 0, so it required 0 steps to reach over here, and it is given that r 0 comma 0 and m minus 1 comma n minus 1 is having is an empty cell, so we don't need to put any number over here, and we are initially at 0 comma 0 coordinate. And this priority queue in by default will return the maximum value. So for taking the absolute minimum value, what we can do, we can put a negative sign over here, so in that way we can get the minimum value. So let's say in priority queue, if I having the value of -5, -1 and -2, so what will be the maximum? So over here the maximum is -1, we know, but the absolute value of this -1 is definitely a minimum one, so we can put the negative values over there, so that we will definitely got a minimum obstacle that need to be removed, that we are kind of taking out of the priority queue. And we need one visited array for marking which all coordinates we have already reached. Yeah, so I mark them all as 0. Now I have already reached position 0 comma 0, so what I can do, I can mark them as 1. Yeah, so this 0 comma 0 we will ensure that we will not put again in our priority queue. So we keep on doing this until and unless we will not able to find our answer, or this queue will not get empty. I will put out the top element from this priority queue. So let's take it as number p, which is equal to the top of it. Now the number of steps that are required will be on the first of that pair, and I need to negate it because I need a absolute value for that number. Now the coordinates, let's say, will be x and y, so it will be on the second of first. So what that second of first means, key, let's say if we have pushed 0 comma 0 comma 0 as a pair, so this is the first and this is the second pair. So in the second pair I need this first value as my x coordinate, and the second of second will be my y coordinate. So int y is equal to p dot second and second. Now I need to take that element out from my priority queue, so I will remove it. Now I will check whether this x comma y which I got are my required coordinate or not, which is m minus 1 n minus 1. So I will check if x is equal to m minus 1 and y is equal to n minus 1. I can directly return whatever number I got, this num. Otherwise I need to explore all the 4 directions, which means if I add, let's say, x comma y, then I need all the 4 directions. So this will be x minus 1 comma y, this will be x plus 1 comma y, this is y minus 1 comma x comma y minus 1, and this is x comma y plus 1, right? So let's do it for x minus 1, and we need to check whether it is valid one or not. So in order to check whether it is valid or not, we can put x minus 1 will be greater than 0, and we need to check whether it is visited or not. So it should not be visited, so this should be equal to 0, and if it not visited, we can put in our priority queue. We can put in our priority queue as, we also need to check whether this x minus 1 comma y is an obstacle or not. So if a of x minus, okay, that is already taken care while putting it in the element, because if it is obstacle we are having 1, and if it's not obstacle we are having 0. So we can put an extra number by considering the value of the coordinate. So a of x minus 1 comma y, this number, so this number required to reach this position x minus 1 comma y, and I need to put both the coordinates, which are x minus 1, the one coordinate which I will be going to reach, and I need to mark them as visited as well. So the same step I need to repeat 4 times for all the 4 directions. So let's x plus 1 will be less than m. I can copy this out, put it over here, and this will become my x plus 1 plus 1, right? And I need to do the same step for y as well. So y should be greater than or equal to 0. So this will remains x, y minus 1, and y plus 1 should less than n, which are the column value, and need to check it should not be visited. the new number of obstacles that need to be removed in order to reach this position. I have considered it over here, and I have put the coordinate again into my priority queue and mark this as visited, so that it will ensure it will not again going to put it in my priority queue. After reaching this, I can directly return any number from here because it doesn't matter, because this condition will always be going to execute because we will be going to reach this position anyhow in the minimum required steps, right? So let me give a try. We are having any errors, so we are having an error over here. So int parent comma int q. Okay, so priority q I have written wrong. Priority queue pair int and q. This need to be there because we are having 1 2 3 not working. Why? So this is my first pair. So I am having 1 2 3. So 1 2 3 is over here. Now I have closed 1 2 1 2 3 4. Okay, unexpected expression over here. This need to be considered pair of int comma int. So I'm having 1 2 and 3. This 3 needs to be there. I don't know why it is not working. Okay, I'm getting a wrong answer. So might be I have missed some cases which needs to be checked. So I taken out the top. Okay, I need to insert the negative values of all of them. Yeah, yeah, now it is working fine. Let me submit it. Not submitted yet. Yeah, submitted. So let me quickly explain you the time complexity and space complexity for this problem. This solution. Yeah, so we are taking this priority queue as an extra space and this visited array. So the in this priority queue we all know the maximum number of elements that can be inserted is m into n, and we are using m into m of visited array. So the space complexity for this problem is n into m, and the time complexity is we are using this priority queue which will be having m into m elements, and for inserting any element in priority queue requires log of whatever number of elements we are putting into it, so m into n, and we are kind of pulling out the elements from this priority queue and inserting all the 4 coordinates of it. Okay, so the overall complexity is not more than m into n log m into n, and it is given that m into n can be up to only 10 raised to power 5, and this log of 10 raised to power 5 is not more than 25, so the solution will go up till 10 raised to power 6 values only, so that's why this solution got accepted. So thank you.